Greetings. Today it was discussed in class that there are multiple ways to prove similarities within triangles. We actually talked about proving congruence with triangles, and that there's the three ways that we do, the four ways that we do it with side, 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 angle, and angle, side. Before we proceed, I want to take a moment to just investigate one of those methodologies. Oh, goodness, I'm having issues already with my pen. Let me see if I can get this thing working properly before we commence instruction. There we go. Okay, much better. Let's talk about angle, side, and side, angle. All right. Now, what we've discussed so far is that we have for similarity, and this is for congruence. Now, what we have for similarity is we have angle. Okay. Now, think about this is that the third angle is automatically going to be congruent between the two sets um, of triangles. So we actually don't even need to consider the side or the side because we already have what we need in terms of a sufficient amount of information. Um, because remember when we have similar figures, all the angles will be congruent correspondingly, and then the sides will be proportional. So I don't even need to worry about these sides because I have what I need. And then we have the two other ways for us to prove this. Let me move this thing out of the way real quick. See if I can kind of, oops. Hope I can move. Oh, there we go. Let's slide this thing down. Well, you guys can see SSS and SAS. Okay, so let's first address SSS. So SSS similarity. Um, which says is that if we have, and it's not with congruence with the sides, remember it's proportionality, but if the corresponding side lengths of two triangles are proportional, then triangles are similar. Okay, so I think I want to make sure that you guys understand when that happens. Let me get my auto shapes thing working here. When that happens, for example, it's my triangle right here. Um, this triangle here, and then I can just pull from this corner to make a slightly larger to scale version where all my angles are still congruent. But I'm going to have triangle ABC and then triangle DEF. And what it's saying is that if I have triangle ABC similar to triangle DEF, I have all the corresponding parts are going to be congruent, or excuse me, are going to be proportional to the same scale. So it would be AB to DE, right? And then the next part would be BC, second and third, right? To EF, second and third. And then last but not least, I would have AC, first and third, and DF, first and third, okay? So that shows my proportionality here. So let's just go jump into an example of what you guys are going to see. It's pretty straightforward, and I don't want to overcomplicate this for you guys. Oops. Here is a triangle. Oops. There we go. Make it where I can copy it. So then I have a slightly smaller version of this triangle. Okay. Let me take my auto shape feature off real quick. I have triangle H, J, K, and then I have X, Y, Z. And then here are my dimensions. I have 30 for HK, I have 15 for HJ, and I have for JK 5 times the quantity X minus 6. For XZ, I have the quantity X minus 5. For XY, I have 3. And for YZ, I have 5. Now, the setup already looks kind of crazy, but here's what I need to make sure that we have established, is that we are going to find the value. The other one, I'll solve for X, obviously, is going to be the target of the problem, or the goal for the problem. but it's how we set it up. It's going to be the trick, right? So when we find the value of x that makes these proportional or similar, okay? And it's going to be triangle x, y, z similar to triangle HJK. Now, this is what's great is that we were given this similarity statement. And this dictates everything for us. Okay. So for example, XY, the first two letters, right, correspond to HJ, the first two letters. So I don't really have to um, overcomplicate things by trying to figure out, oh, where's my proportion, this to this, that to that, because it would be undefined for us. For example, these guys correspond, but we have, right, this is not a statement because here we have these unknown values, right? So we need that similarity statement for us to set up these proportions, okay? So we had XY first and second, HJ first and second, okay? And then let's take a look here. We have JK, right? This guy right here that has a value for X. So 5 JK, which is going to be second and third. Okay. And that's got to go down here with HJ, corresponds to that triangle. So JK second and third is going to go with YZ second and third. Okay. So now we have left triangle, okay? And we have right triangle, and we are good to go. That way we have these in the correct corresponding space. Excuse me for a moment. Apologies for the slight delay. Um, Now I just substitute, right? So for XY, as you guys can see, XY is the value 3, HJ is the value 15, YZ is the value 5, and JK is the value 5 times the quantity x minus 6. And now I just have an algebraic problem, guys. Here, few ways I can go about this, right? I could just take my simple cross product here and let's just go ahead and do that. Could I simplify first? Sure. Let's just go ahead and just do this, right? We take our cross product. I'm going to go 15, right? 3 times 5 times the quantity x minus 6. And then I have 15 times 5, which is a really easy problem. It's 75 because we just punch that into our calculator to make that so easy for us because the machine works for us. And then I'm going to get x by itself. So rather than distribute the 15, I'm going to divide both sides by 15 because calculators divide by 15 rather fluidly for us, right? So 75 divided by 5, which we had already just multiplied by 5, right? So that's going to give me 5. And then I have this quantity, x minus 6. So I'm just going to add 6 to both sides. It's going to, all right, I can just get rid of these parentheses. That's going to knock out that 6 and cancel it on the left, or the negative 6. So x is equal to 11. Okay, and there you go. That's it. Last part of the lesson is involving our second theorem here, which is SAS similarity. So let me illustrate this for you guys. Remember, if you guys have any questions in the chat, you're always free to ask. Okay. Here we go. I'm gonna erase. We got an extra little speck in there. Let's go ahead and get rid of that. Oh, looks like I do have somebody in the chat just wishing me good evening. Somebody whose username ends in 67. That's interesting. Here we go. SAS similarity. And we work like this. I'm going to have triangle XYZ and then triangle MNP. Right. Now, are these similar? I don't know yet. Okay. And here's what I would need to know. First of all, I would need congruent corresponding angles. So we have X and M in this case. All right. So here's how we could determine this. If, this is our SAS similarity, if angle X is congruent to angle M, which it is, and then we have another thing is that we'd have to make this side and this side correspond, right? That are going to, where the angle X is going to be included or sandwiched in between. So it would be XY, right? And XZ as my two sides from one. And then it would be the left, right, and the right with the included angle M. So MP to MN. Okay. And now these aren't congruent, but it's just more so I have this side and this side. Okay. And then I have this side and this side that are going to correspond. And you guys can see the angle that's congruent is included. Okay. Get rid of those little marks. Actually, they're okay. They can live here. I like them. Gives it some fun color. All right. So, getting back to it. If this is the case, then triangle XYZ is going to be similar to triangle MNP. All right. And here's how it'll work. You guys ready? We are going to have an interesting thing happen here in our next problem. Okay, so let's go get my auto shapes thing going here again. Draw. Sure, this is actually kind of to scale as much as I can. Yeah, there we go. Like, I'm going to make it a little more elongated just so you guys can see it a little bit better. Okay. Still not really happy with that one. There we go. It's a little bit better. All right. Here's what I have. I have a right triangle. Okay. And here's something that's going to happen is that the altitude of a right triangle creates three similar triangles. Yes. All right. Now this is critical. Okay. Watch. Let me take that altitude, right? From this right angle, I'm going to drop down perpendicular to this other side right here. And now I have three similar triangles. And it should be straightforward as to why, right? Because let's take the first outer triangle, the big guy. He has a right angle. There's a right angle right here as well. So that's two angles. And think about just this triangle, which has this angle, and this triangle, which also has that angle, as well as two right angles. So through angle, I have similar triangles. Moreover, let's actually take this big triangle, right? He has a right angle as well as this one, and then they both include this angle. That makes through angle similar. And if this triangle, right, the medium, the small, and the large, right, or if the medium and the small are similar to the large one, then they have to also be similar to each other. So here is how this will work. I'm going to solve for x, okay? Given that I have 9, 12, 15, okay, as my sides here. And if that's the case, 16 will be this side length as well. Okay, so how am I going to relate this? Well, think about this. I have a long leg. There's three parts, right? There's a long leg. There's a short leg. Those are the adjacent sides to the right angle. And there's the hypotenuse. Okay, so x is my hypotenuse. I'm going to relate the x to the other hypotenuse that I have. And in that case, let's say it's to the big triangle. which is going to be 25. Now, what do I get the 25? It's the 16 plus 9, right? So I'm working with this outer triangle. And then I'm going to relate that to, let's take this small triangle, right? I have the hypotenuse, right? It was x over here. But now for the small triangle, it's 15. Okay. 2. And then, I'm sorry, guys. I did the big triangle. This was the long leg, right? Versus 15 was the short leg. Now, if we're not sure, we can actually go back here. So the long leg here is going to be 12, right? So this is because 12 is bigger than 9. And then the hypotenuse is 15. Now, another way we could have gone about this, okay? I'll do this on the side because when I do this problem, it's going to be pretty quick. I could have gone long leg to hypotenuse, 16 to x, and I'm going to get the same thing over here, 16 to x, long leg to hypotenuse, right? And I could go long leg 12 to hypotenuse 15. Long leg 12, hypotenuse 15. Now watch what's going to happen in both cross products, right? I'm going to get the same exact thing. Okay. 15 times, let's do this one over here. 15 times 16. It's an easy problem, right? Because according to our calculator, oops, 15 times 16 is 240, okay? So I have 240 is equal to 12x. Divide both sides by 12. And again, 240 divided by 12 is an easy problem because we are in charge of the machine, right? 240 divided by 12, you punch it into your calculator and you will get 20, and that's x. Now watch what's going to happen when I do this over here, okay? Same deal. 15 times x is going to be 15x. 25 times 12, you punch it into your calculator. What do we get? 300. We divide both of these by 15. 300 divided by 15, according to your calculator, is, of course it has to be, it's 20, right? So pretty cool. It kind of shows all three of these triangles related to each other. It doesn't really matter which way you do it, as long as that we kind of set this thing up consistently. So there you go. I will post this to Canvas. If you have questions, see me during office hours tomorrow morning. Good luck.